And good afternoon, and welcome back to another Tech 20 Tuesday. I hope you all enjoyed a wonderful spring break. Some of us got down south, and for those of us who didn't, I hope you enjoyed just getting that rest. And hopefully you learned a few things over the March break as well. Today on Tech 20 Tuesday, I'm very pleased to invite and very pleased that he accepted Tech let's try that again. A technology mentor, a learning lead from School District 14, my good friend Waylon Dixon, and any of you who are on Twitter can follow him at TechMental. And Waylon today is going to talk to us about Scratch. And Scratch is a programming language, a programming application, I guess, if you will, that was developed at the Massachusetts Institute of Technology, the MIT Tech Lab. You know, a lot of people, a lot of educational technology leaders, Dave Warlick, Mark Prensky, others, are really pushing programming as a way for our students to understand the world around them, and they should have a basic knowledge of programming. And so I'm really kind of excited to hear a little bit about Scratch. I really don't know a lot about it, but Wayland is going to be here to join us. So Wayland, how are you today?
I'm well, Jeff. Can everyone hear me?
Oh yes, we can hear you fine.
Excellent, excellent. I'm very happy to be here on this hopefully snowy evening.
Well, so tell us a little bit about Scratch. We've got 15 minutes or so for you to walk us through it.
Perfect. 15 minutes is about my range. So if everyone can see my desktop, I'm just going to start with a little Scratch animation here. And let's start. There I am. I'm going to actually go full screen on this. So, Scratch. Hopefully you enjoyed that, and you may have recognized a character or two in there.
I've seen that guy before.
You've seen that guy, yes. Just to get started, yes, as Jeff mentioned, Scratch is a computer programming language, a very simple programming language in the sense that it's based on blocks rather than having to learn a bunch of code. It's kind of a building block approach to it, similar to like clicking blocks of Lego together. Each block represents some piece of code. And just to kind of talk about Scratch as a bang for your buck, I would like to mention that Scratch is free. I'm going to just go to the website. This is it's an MIT product, and if I can zoom in on my screen here, I'll just show you the website here if I can. No, I can't. Oh, there it is. Scratch.mit.edu. That was a failed experiment in screen zooming, so we won't do that anymore. And it's a free program. And one of the things I like about the free programs is that everyone can afford it. It's something that the students can take home with them, that we're not just licensed at school, that they can take anywhere with them and use, so the learning and creativity continues beyond the classroom. And it's also cross-platform in that it has a Mac version, a Windows version, Linux, if anyone is predisposed to that. And it keeps its older versions archived, so that even if you had an older spec piece of hardware, such as a Windows 98 machine, they have a version that will run on that. So I really like Scratch for that reason. I'm going to bring up the window here. This is what the Scratch, when you open the application, it looks like. And you can do all sorts of neat things here in terms of creating animations or slideshows. An animation kind of like the one you just witnessed. Sorry about that. You can create games and interactive demonstrations. Now, Scratch, I will mention, is one of these programming languages that are out there. There are others, Alice being one. There was one someone mentioned today. Jeff, you sent me a link about one today, and I can't remember. Atmosphere, I believe it was, which I haven't used. But the value in these games, Scratch being one of them, is that it really fits in well with our 21st century skill development in the classroom, and the idea that we want students to be creative, personalize their learning. In the sense of programming here, there's really a lot of opportunity for reflecting on things that they've built, troubleshooting when things don't go quite the way they expect. And once you get beyond the basics of learning the technology of the programming, it really opens itself up to any curriculum, and that this, hopefully not necessarily just Scratch, but any kind of programming language would afford students the opportunity to demonstrate their learning in a variety of ways, right? Not just the standard old book reports and such that we're accustomed to. So I'd just like to maybe start with a Scratch one. I'll just show you a new one. I'll just go blank one. I have this saved, so I won't bother. This is Scratch over here on our right-hand side. It's the default character, or I should say it's a sprite. You notice that we have different things here. We have a kind of our world where we view what's going on here. We have a area down here that shows all our sprites, and sprites can be characters, they can be objects, basically any element that you insert in here. We also have a stage, which is our background. In this case, just that white blank background. And every time we click on an element, it comes up here in the center section. You see it's called Sprite 1. And what we would do is we would actually build scripts. And scripts are just like it sounds. They are the actions, the words, the thoughts, the reactions that this sprite or character will go through. The program itself is broken down into these blocks, and there are 8 categories of blocks that contain various controls or code blocks. So for example, I have my character Scratch here, which I can grab and move around here rather, and he reacts to the scripts. So if I've got him highlighted here, Sprite 1, and I'm going to go make sure I've clicked on my script tab, and I would go to control, and I can create some input controls for my Scratch cat. So I would just drag that out, and it's as simple as that. If I don't want it, I drag it back and drop it, but I'm just going to click and drag that in, and now I'm starting to build the code. So what I would say is that this is a control. So when a button is pressed, and I'm going to say, I'm going to just click on that arrow, and I'm going to say when my left arrow is pressed, I would go back over and I would say, okay, what do I want to happen? On motion, I want him to move 10 steps. Now, I should mention that the world is kind of based on a coordinate plane. I can bring that up. I'm going to import a coordinate just to give you an example of what this would look like. You can see that we have an X and Y plane, and it measures 240 by 180 is one quadrant, and then we have our negative values. So we have a negative 240 and a negative 180 to the bottom. And that dictates or helps us determine what motions the cat's going to go through. So when I go to my cat, say 10 steps, to the left is actually negative 10. So I'm just going to click in that box and type negative 10. And so now you'll see that if I click my left arrow, you won't actually see me. I'm clicking my left arrow. He now moves 10 steps to the left. To continue the control, I would add another piece of code. In this case, I'll say when the right arrow is clicked, I'll go back over to my motion category, grab another block. It says move 10 steps. This is a positive 10, so this will be to the right. You notice I just click that into place, and it highlights when I get close, and it'll snap right in there. And now if I move my right key, it moves to the right. My left key moves to the left. Pretty straightforward. Let's see here. I just want to check the, whoops. place this anywhere and start my animations anywhere on that grid just by clicking and dragging. And as I move the cat around, you'll notice down here in the lower part of the world, it actually tells me the coordinates that my mouse is at. So when I drag this cat to almost the center, I'm getting pretty close to 0, 0, or the origin, right? And down here I have a positive x value and a negative y value, both a positive x and y appear. So this helps me coordinate movements or determine my starting points or finish points for certain characters. Now, the next part of the sprite is we can create costumes. And costumes are just different looks. So for example, when I press left or right, when I'm pressing right, it looks like the cat's pointing in the right direction. But when he's going to the left, it looks like he's walking backwards. And what I'd really like him to do is face the other way. So what I would do is I would create a new costume for him that actually has him facing the opposite direction. So I'm going to copy this costume that's highlighted. I'll go down here. It's now costume 3. I'm going to edit this. And this brings up a little kind of pixel type editor, kind of similar to Paint. Very similar tools. We've got our color palette, text tool, an eraser, different things like that. But in this case, all I want to do is I just want to flip my character horizontally so he points to the left. And I'm going to click OK. And then I can actually edit these. I'm going to call this one Scratch right. And I'll call this one Scratch left. I'll put an F in there so I know that. So now when I go back to my scripts, I can actually add something to this. So I'm going to break this piece apart. If I grab the bottom part, they just snap apart. If I grab the top, it all moves together. But if I grab the bottom piece, I can break them apart because I want to do some modifications here. I'm going to change his looks. So when the left arrow is, when I click the left arrow now, I want to switch to the costume Scratch looking left and move the 10 steps. And for the right arrow, I drag this in again. And there's a little drop now because he has more than one costume to choose from. I have drop down. And I'll have those two pieces of code now, so we'll see what happens. So now when I point to the right and point to the left, he switches costumes, or rather just gives us a new look of that character. So now he's pointing in the direction that he wants to walk. And this is the basics of how you would create an animation, and that you would create different costumes that the character would switch between. Another costume, actually, we have one created for the right. And I'm going to see if I can create, I'm going to just put in a little wait command here. Timing is very important, and students will learn this quickly, that they'll think they've got something created, and they'll look at it and go, that doesn't seem quite right. And they'll figure out they have to time things because each sprite works on its own script. So you kind of have to wait for one thing to happen for the next, before you want the next thing to happen. So you have to time things. I want to switch to, I want to change my looks again. I script on the left. And then what I'm going to do is I'm actually going to put in a loop. And we're going to do a little, move 10 steps, put that in there. I'm going to drag this over top of it. Oops. Like that. And then drag that whole box to connect with my right arrow. And now what you'll see is he should, well, I have to play with it a little bit, but his feet kind of look like they're moving a little bit. I can do a better job than that later on. Let's see here. So that's the basics. Drag and drop different blocks to create scripts. They have costumes. You can also, there's different sounds. Oops, a little meow sound. Now, one of the great things about Scratch is that it allows students to learn, or different people to kind of get involved differently, in the sense that not everyone has to tackle Scratch the same way. There are, if I can bring this up here, Scratch. If you log into the Scratch site, there's all sorts of different projects that people have put up, they've shared with others. And by creating an account, and that's totally free, you can look at any one of these projects. And I'm just going to do a quick search here for a math project. And let's see what we have here. I want, math projects. Great. First thing. Different math projects that people have put up. Oh, I remember the one I want to look up, Pascal. And, sorry, bear with me 1 second. Pascal's triangle. And there's a little project here. This one's in Spanish. It's worldwide. This Scratch program. And the bees is the one. Oh, my bad. Regardless, logged in with my account, I can see that I can download the actual project, and it will show me all the code that is in this Scratch project. So if I see something that I like, I can go in and see how people have actually done that. So I can analyze their code to learn more about what I want to do if it's something that I thought was interesting. And you can see it downloads all the scripts here in the center window and all the little sprites that are involved. And I can go in and I can play with this and modify it to create something new or remix it. So that's one way that people can learn about Scratch, just by looking at other people's works. Some people prefer the trial by error or just kind of tinkering method, in which case they might just grab Scratch as such, drag something in, right, and just see what happens when you click a block. Say, oh, that's interesting. Or what happens when I click this one? Oh, he rotates. So there's a kind of the tinker method. Now, the way that I've done this, and I've done this kind of as an enrichment with as low as grade 3, it's kind of I would say the age group is about an 8 to 16 group. But I've gone into if you go to the support section here and look, there is a whole set of Scratch cards. And that's the first link here I'm going to click. And each one of these is a PDF file. There's 12 of them. And if I just click on one, for example, this is similar to the one I was using. And I'll zoom in a little bit. It shows you exactly the blocks and code and values to put in, and basically allows you to recreate a key concept. In this case, it's movement by using the keys. They have them for movable beats, for incorporating sounds, how to have an object speak, right? So there's a say piece of code here that they could put in. So the Scratch cards, by completing all the Scratch cards, students would have a basic understanding of the key elements or key concepts in Scratch. And at that point, they may be ready for creating something on their own, or perhaps a project assigned by a teacher. So, I'm sorry, how are we doing for time, Jeff? I haven't looked at my clock.
30 seconds.
30 seconds. Okay, and that again is the great thing about Scratch, is that I really can't do it justice in 20 minutes, but it's a great way to lose a couple of hours if you just have nothing else to do, I guess. Or if you're looking for something new for your classroom to share with your students. Great for open-ended types of projects. It's free. What else can I tell you?
Question I had really quick, and if other people may have
Yes.
questions as well, they could open up their mic or they could just type it in the chat box.
Sure.
Can students import their own voice, other audio, or even some of the little characters?
Yes. If you recognize, like say, let me go back here. You can import sprites. So for example, you could paint new sprite. You can actually paint your own in here,
Okay.
or you can import, in which case, if you remember me, I had actually gone and created my own. I'd gone to one of those avatar creation sites, created my own, and then imported that, played with it inside of here, or they could do it from another editing program. You can, in your backgrounds, for example, in a stage, you can take a picture of your own classroom or your own, your own soccer field and import that as a background for your, you can bring from camera. You notice that option here. There are a number of ones that come with it, right? But you can basically put anything you want in there.
Hey, that's my bedroom.
Any other questions? Same as sounds.
Yeah, cool. Well, Zal says your avatar has too much hair. Yeah, nice guy.
Thank you, Zal. Yeah.
Well, thank you so much, Waylon, for spending this afternoon with us. And thank you. We got a big crowd today.
Excellent.
Yeah. So, and I know there was a lot of interest. I got 3 or 4 emails today from people who couldn't make it today but wanted to know if it was going to be archived, and of course they all are at Tech20Tuesday.wikispaces.com.
So, like I say, if I could just add one more thing, like as I mentioned in the kind of the little blurb there, that when kids get on computers, and my kids are no different, that one of the first sites they want to go to is a mini clips to play those pop games or whatever they are. Mm-hmm. And as much as we say games are good for students being creative and problem solving and things like that, I really like the fact that this may allow them to create the game that they're going to play.
Yeah, powerful stuff. I mean, this is great in terms of there's lots of math in here and literacy and digital literacy as well. Well, thank you so much for this afternoon, Waylon, and thank you everybody for joining us. As always, if you have any questions, you can always go and find your local technology mentor, and they can try to help you out. If you're looking for to download Scratch, just a reminder, you do have to download it. So if your district doesn't have admin rights for teachers, you can always put in a help desk case.
There is a non-admin version.
Is there?
Yeah, if you download the zip file version, it will play right off your desktop.
Excellent.
Or off a thumb drive.
There we go. Things we learn every day. And thank you all. We'll see you again next week for Tech20 Tuesday, when we'll start looking at a few portal tools. But for now, thank you all, and we'll see you again next week. Bye-bye.